So now that we've learned the basics of probability, we'll now move on to another statistical concept, hypothesis testing. Hypothesis testing is used to analyze data to see if the data sufficiently supports a certain hypothesis. And there are two hypotheses that we will go over. The first of which is the null hypothesis. The null hypothesis is a statement that states that there is no relationship between two variables in the data. So when we are testing and doing hypothesis testing, we're testing against the null hypothesis in favor or not in favor of the alternative hypothesis. So the alternative hypothesis is a statement that states that there is a relationship between two groups within the data. So how will we find this relationship or lack of relationship? So when we're hypothesis testing, we must use a test statistic to study the relationship between the distribution of variables within the data. The test statistic helps us understand how far your observed data is from the null hypothesis of no relationship between the variables or no difference between the sample groups. So there are many different test statistics that you can use, and it's really dependent on the data set itself, as well as the alternative hypothesis. Some examples are the difference in means between the two variables in the data or the difference in medians between the two variables in the data, but there are several different test statistics that could be appropriate for your specific hypothesis testing experiment. And once we calculate all of the test statistics for the data, we then calculate the p-value. The p-value is the probability that the test statistic of an assumed probability distribution will be greater than or equal to, or on the other hand, less than or equal to, observed results. So the p-value is this area under the curve. And why is this p-value important? Well, it's the probability that the test statistic is really belonging to a different distribution than the one that we assume it is, the null hypothesis. And after calculating the p-value, we think about significance levels. So what is a significance level? It is usually given at 0.1, 0.05, or 0.01. And basically, the results of a hypothesis test have significant statistical significance when it is very unlikely to have occurred given the null hypothesis. So if your p-value is less than 0.1 or the given significance level, then this is statistically significant. Then we reject the null hypothesis. So the p-value is given in this example here at a 95 statistical significance threshold or 0.05. That's a cutoff line right there. Our real observed value is farther than that, so it's probably unlikely to have occurred given the distribution under the null hypothesis. So that's basically what a significance level is. It's an arbitrary value to which we decide whether to reject the null hypothesis or not, given our p-value. So when we're drawing conclusions on our hypothesis testing, we reject the null hypothesis when the p-value is less than the significance level. On the other hand, we accept the null hypothesis when the p-value is greater than or equal to the significance level.